Okay. Looks like easy today. Also on matrices, which has been the theme for this month, I feel, or this past week. Determine whether a matrix can be attained by rotation. Given two n by n binary matrices, mat and target. Return true if it's possible to make mat equal to target by rotating mat in 90-degree increments, or false otherwise. So here, rotate by 180. No, rotated by 90. Either clockwise or counterclockwise. Here, it is not possible. Obviously, it needs to have the same number of ones. And here, it is possible. This is the start, and this is the end, and this is the intermediate. Okay, I mean, there's only 3 kind of variations based on rotate 90, 180, and 270. So, I mean, you can do just direct comparison, I guess, of the position and it's 3 each position, and it's 3 each position, it's 3 corresponding positions at 9 degrees clockwise, 180 degrees, and 9 degrees counter. I think it makes sense to have them separate for loops and have an early break of any for loop that fails. No, it needs to fail all 3, right? I guess it's early true if it passes. Okay, early true. So here I guess it's gonna return false if nothing returns true before that. So here's gonna do check for, I think, 180 degrees rotation is the easiest. So for every, let's say, rows and columns, actually it's just a square matrix, so n is equal to the length of the matrix, which is going to give me the number of rows. And then for every, let's say, r, which is row index in range n, and for every c in range n, so the position rc corresponds to the position like n minus r c n minus c, complementary row, complementary column. Yeah. RC corresponds with like n minus r, n minus c, or maybe n minus r minus 1. I think it's n minus r minus 1, since it's inclusive of index. So I guess I need to do an early true, or I break if it doesn't match. So I assume that it matches, and then I break early if it doesn't. So if the matrix at RC doesn't equal the target at n minus r minus 1, n minus c minus 1, then match equals false break. I don't want to break out of the nested for loop, we just only want to break out of the inner for loop. I think I'm actually going to do a helper function then, just make it have a way of breaking out of the thing. So I'll do check 180. Yeah. And this is just going to return a boolean. So this is going to return, I guess it's just return false immediately here, right? Short circuit false. And then return true otherwise after completing all the elements. And then I'll do a check for 90 degrees clockwise. 90 clockwise is CW, I think. My syntax is pretty bad. I guess that's probably fine. For R in range, and for C in range, and so RC corresponds to 90 degrees rotation around the center. What does it correspond to? So if it rotates clockwise, you okay. I think there's some math behind this. 90 degrees rotation for X, Y is like, I used to know this. It's like a vector thing. Yeah, it's like a vector thing, right? So it's what is the square matrix that you multiply by? So a vector 1, 1 becomes the vector AB becomes, if I imagine A is, let's just use numbers here. Say 10, 5, that's in the first quadrant. That should become, rotate clockwise would be positive 5, negative 10, 10, 5, over 10, up 5, over 5, down 10. Yeah, okay, so it looks like it corresponds to AB corresponds to B negative A. I think that's right. That's assuming the center is 0, 0 though. Yeah, that's assuming the center is 0, 0. So in this case, what would it be? RC. I have to translate RC into something like 0, 0 for the center. So I mean, I could do RC corresponds to, I could do a translation of RC to like R minus n divided by 2 C minus n divided by 2. Would that work? I'd have to translate again afterwards too. Have to do a reverse translation. Or I guess it'd be inverse translation. Probably some better math here. So 0, 0 corresponds to 0, 2, and 0, 2 corresponds to 2, 0, or 2, 2. Oh, my poor non-linear algebra brain. At one point in time, I could be able to do this pretty easy. Let me see. So this thing goes here. Yeah, I mean, RC becomes C comma R even? Is that right? RC becomes CR? Because it's almost like this row, the last row becomes the first column. The last row becomes the first column. So it's not quite. So I'm thinking, so last row is going to be 2, 0, 2, 1, 2, 2, 2, 0, 2, 1, 2, 2, and then that translates to the column that is 0, 0, 1, 0, 2, 0. So the row translates into kind of a complementary column, like n minus r becomes the c, n minus 1 minus r becomes the c, and then the elements within that row, or the columns within that row, corresponds to the exact same row. Okay. So RC corresponds with C and then n minus r minus 1 with column. So if the matrix RC doesn't equal target at C n minus r minus 1, okay, hopefully that works. Okay, so here for R in range n, so counterclockwise. So this is clockwise. So the general pattern is RC corresponds to C n minus 1 minus r. So counterclockwise, if I do, should this be the reverse, right? So from here to here. So 0, 0, 1, 0, 2, 2, 0 becomes 2, 0, 2, 1, 2, 2. So the column matches with the row. Column matches with the row constantly. And as the row increases, the column increases. So I think here pattern is RC the value of the column matches the row. No. The value of the row matches the column. Zero, 1, 2 becomes 0, 1, 2 there. And the value of the column matches the row. So n minus 1 minus column. Okay. If matrix at RC does not equal matrix at or target at n minus 1 minus C R. Okay, and then it needs to return, if any of these things return true, then immediately return true. I guess I can just say if, I can just do an OR, right? Return check 180 or check 90 clockwise or check 90 counterclockwise. Okay, let's see if that works. Probably not. Oh. Ominous, ominous. Okay. Ooh. So the output here should be false, but return true. Interesting, okay. Alright, see which one it passed. Oops, I forgot to add this to my test cases. Oh, I said it was false, but it's supposed to be true. Oh, it's the identity. Okay, sir. Alright, alright. Okay, so let's go ahead and just do the simple check here for everything in range N, for every column in range C. If the matrix at RC is equal to the target at RC, or I guess not equal, return false, return true. I need to add this to my test cases, or to my actual thing. Cannot access local variable C. Oops. Hopefully this works. Okay, cool. I don't know if this is particularly easy, but I guess this would be very simple for medium. Considering mediums can definitely stump me pretty bad. Okay, so summary here. The size of the matrix is pretty small too. Okay, summary. Decomposed the problem into smaller, kind of smaller checks, using helper functions, where checks would do short circuit evaluation if target fits a certain rotation of the matrix 0, 90, 180, 270, or 270, I guess, clockwise. In each helper function, have nested for loop that iterates over all positions RC and checks if it matches the corresponding position of the rotated matrix by whatever degree it's checking for. Degree rotation. If it doesn't, short circuit, return false. Return true if finish after the nested for loop. Need to be careful about figuring out what the corresponding position based on rotation would be. I use the kind of test case numbers and generalized the variables as the technique to generally figure out that. Okay, and then call the helper functions in your main with appropriate OR logic. Right, so like checking for 180 degrees iterates through all the indices, C iterates through other indices. Target is going to be, for RC, it's going to be n minus r minus 1, n minus c minus 1, or n minus 1 minus c, whatever. return false if it doesn't match, short circuit logic there, return true if it doesn't short circuit within the loop, and then just make sure you have the correct positioning for RC compared to whatever it rotates to. And here's kind of the logic of some examples. Okay, time complexities can be O of n squared, since each check will iterate over every position, doing constant work, and there are n squared positions. Space complexities can be O of 1 since no extra space.